So the first step is research and observations. You can add observations to that column. Okay, and you've either just done some kind of looked into something that you've noticed, or maybe you saw online and you started reading further about it, or maybe it's just an observation that you've made. You know, and it wasn't just like a fluke. It's like something you've made that's like maybe a trend that you want to investigate. All right, so so I'm going to say that you did some research in the effect of caffeine on the body. Okay, so I'm just going to put effects of caffeine. Okay, so you're just kind of interested in, you know, why does it seem that maybe caffeine makes me go to sleep at night, or maybe why it keeps me up, or maybe why does my heart rate kind of increase after I drink something caffeinated or eat something that has caffeine in it. So anyway, you're just kind of doing some research on that. So a problem or question, that is really the focus of your experiment. So this is this kind of what starts off your experiment. So this is the focus of your experiment or process. Okay, so what could be a question that you could ask as far as caffeine and how it affects your body? What could be something you could possibly be wondering?
What does it feel like in the brain?
Okay, so it's going to be harder for us to do that because we can't talk about electrodes and all that, but that would be one. But let's do one simpler that we could actually do like here. Will be another idea. Heart rate. You can say, you know, does it increase your heart rate? So I've got a little attention deficit, and because of that, at night, if I'm really, like a lot's been going on during the day, and I'm really tired, but I'm not really that tired. If I go to bed, my brain is racing in all these different directions. I'm making lists in my head. I'm thinking about this and this. So I've noticed that when I drink a cup of caffeinated coffee at night, it actually makes me sleepy.
It does nothing.
And it's because it's a stimulant. So you wouldn't think that it's actually counteractive for me. So just because, but it does make my heart elevated. So I might be thinking of all this thing and all these different things and thinking, okay, what is it that I'm going to test? Now, can we test multiple ideas with one experiment?
Yes. No.
You can't test all these individual things within one experiment because you have one problem that you're going to be investigating and coming up, you know, developing a hypothesis for. You can't investigate all these different things that simultaneously in one experiment. So as a class could do that. So we could say half of us are going to investigate this, and the other half are going to investigate this. But you can't do it all at one time. Otherwise, you don't really know if your effects are what they really are, or what variables causing that. So let's see. So let's say that our problem, let's use the heart rate thing. So the problem or question is, does caffeine stimulate an increase in heart rate? Okay, or you can use another synonym for that. We want to try to use level 2 words. We don't want to try to, you know, use this. We could say, does caffeine make your heart rate go up? Well, but you could say, does it make it increase? Okay, so we just want to try to use those other kind of tier 2 words, those other tier 1 words. Okay, so here's our question. So hypothesis. Everyone usually says this is an educated guess. I hate that because I think it's more than a guess. I think you've done some research. You have some pretty well thought out information that's in your head, and you might have something to back up your claim. I mean, it could be a guess, but I would say it's a predictable. It's actually a testable statement, or your testable prediction of what you think the answer to that question is. So, so normally what I say here is it's a testable prediction. It is what you believe is a possible answer to the question. Or the problem. Okay, so it's what you think the answer could be. Now there's something that in this AP that we call the null hypothesis. And we're not going to get into that, but that just shows you that's one way that we'll actually expand this even more when you take an AP class. Or statistics. If you take statistics as one of your math, you'll talk about that. So a hypothesis is really a cause-effect statement. It involves two variables. You're manipulated and you're responding, or independent or dependent. And a lot of times we want to use an if-then statement. So if this happens, then this is going to happen. So you're going to make a prediction. You don't always have to use an if-then statement. You can just make a statement, but both of those you can't just say it will cause it to go up. It is what is going to cause what to go up. So you have to be very explicit in your language. So when we get to this, what is one possible hypothesis that you could make?
More caffeine increases your heart rate.
More caffeine will
increase heart rate.
Okay, so instead of saying more, what did you say? Okay, and so we can eat or drink it. You could be explicit and say if you drink it. Okay, so if you consume caffeine, then your heart rate will increase. Okay, what's another possible hypothesis?
You become vapor if you have too much.
Well, if we go back, we're going to focus on the heart rate part. And we can measure maybe hyperactivity two ways. We can say it could be maybe the effect of the heart rate going up, or it might be in other behavior. So we would watch the behavior of the person and record it as that, how did they react? But we don't want to really, let's kind of stick right with the heart rate. We won't even assume it's hyper. But maybe. All right, you can also say that if you drink or if you consume caffeine, then there'll be no effects. Heart rate will remain constant, or there'll be no effect on the heart rate, or it will decrease the heart rate. So whatever it is, you just make your prediction. Okay, so a person increases or consumes caffeine. We can say stimulate their heart rate, or it will increase heart rate. Or you can just say caffeine increases the heart rate of humans, or something like that. All right, so we have two variables inside of there, and we would need to actually develop an experiment that's going to test those variables. So that's the next part. So number 4, we're going to try to set up a controlled experiment. So what does that mean to be a controlled experiment, do you think?
Like variables you can, unless it changed, we can't change.
How many variables would you actively change if it's controlled?
One.
Just one. So yeah, you're going to change. You're going to give one group some special treatment, that one variable. So how do we control everything else to make sure that it's only this variable that we're looking at the effects of and not multiple variables? Okay. I think I've let you talk a lot. All right, let's see. I think you know the answer. Let's just work it out in an example and you'll see. So, so the design and conduct an experiment. So this is how we're going to test the hypothesis. With a controlled experiment. Now, so there's different ways of doing that. For it to really be a valid controlled experiment, you do have to have two groups. Now, you may have multiple experimental groups within your group, and I'll give you an example of that in a minute. But control group and experimental group. So which of these is going to be only for comparison? So if it's the caffeine group, the ones that are getting caffeine, are they the control group? Or are they the experimental?
Experiment.
So why would you have a control group? What's the whole point of that?
To compare it to.
To see differences, right? You need to know. Now, here's something else to throw out. If I were doing this experiment, let's say I was going to do it on you guys. Okay, so you all have little heart monitors, or we can just say we're going to count it. That would show a lot of experimental error. But let's say that you had like a little heart rate, or the little clips they have at the hospital. Okay, that's what monitors blood, your blood oxygen level and your pulse rate. So let's say we all put one of those on you, and I gave you a card when you came in. It was either red or blue. Okay, you don't know what red or blue means. You asked me, I was like, I don't know. So I personally know that red means caffeine, so you're going to get a caffeinated Coke. And if you have blue, you're going to get a decaf Coke, okay? Because even decaffeinated coffee has some caffeine in it, so I'm not going to use coffee. So you don't know that. You're just going to get a soda, and it's Coke. And we're going to make sure you have no allergies to that. Everybody's good to go. You have your little heart monitor thing on. You're going to drink your Coke until all of it's gone, and then we're going to measure your heart rate. But why would I not want you to know if you're in the caffeine group or the non-caffeine group?
Because normally if you know that you're being tested, you try to act normal, and that would affect normality as a whole.
And the data.
Might change which one you pick because you like a certain one better. You don't like some caffeine stuff, or you like caffeine.
That's true. You already have a predisposed opinion about something, so you're like, oh, that's nasty. I know that's not going to taste good. And then you're all worked up. Like, I'm having to drink something I don't like.
Sometimes, like, if you keep on being told something, like if someone tells you you're sick, you actually believe you're sick. So if you are told that you have caffeine, you think your body's going to react to that.
That's Munchausen's by proxy. When people can tell you you're sick, and have you heard of parents making their kids sick? There's a Law and Order episode. Great. I've had a student that was like that. And I had to report it because I suspected it. And so every time he started getting really healthy, he was coming to school. He does really well in school. All of a sudden, he's sick again. Mom would pull him back home for some reason. So I watched it, and so I reported it. I don't know if anything ever happened about it, but yeah, I agree. So that's called the placebo effect. So the placebo effect. So you don't need to know, if you're a human test subject, you don't need to know which group you're in. So when my husband was in an asthma study, he didn't know it was at Baptist, and they pay people to do this. He just wanted to sign up for it because he has asthma, and he thought, I'm going to see if there's a new medication out there that works well. So if you watch the papers, a lot of times they're looking for test subjects, even teenagers. And you get, it's kind of cool, but you go through a battery of questionnaires and, sometimes health assessments. But anyway, when he did that, he didn't know if his inhaler had medicine in it or not. He just knew it was a swooshy kind of inhaler, and he just did it, and they had to monitor his, I know that he had to monitor his heart rate, and I don't know how they did his lung capacity. It might be when you blow through that little thing to see how, I don't know what it was. But anyway, that's the placebo effect. So the control group is not going to receive the independent variable, the manipulated variable, what I call the special treatment. So, so this is the individuals that do not receive the IV, which is what I call the special treatment. Okay, so this will be the group that doesn't receive caffeine. People given decaf soda. Okay. All right, so our experimental group, individuals that receive the IV. So these, what are these going to get?
The caffeinated drink.
good soda. Okay. All right. So now we've got our two groups, and we're going to monitor their heart rate. So what is the special treatment that we gave them? Is that the independent or the dependent variable?
Independent.
I don't know.
Wait, say that again?
All right. So the independent variable is the special treatment. It's called the manipulated variable. Manipulated. Special treatment. So this is where folks will get it confused sometimes. They'll say, well, that's the group that got the caffeine. No, that's the actual caffeine itself. So the group will be the experimental group, but they get the caffeine. So the caffeine doses, or in this case, the drink with that percentage caffeine will be the independent variable. All right, so what is the dependent variable? It's called the responding variable. So what are we monitoring again? Heart rate. Yeah, so here's heart rate. I'm just going to put as heart. Here we go. And so this is going to be the result, or at least the predicted result of the IV. So what's going to happen now, you may not notice any difference, but it's at least what you predicted there might be a difference in. So what are the constants? These are also called the controlled variables. Okay. Madison, go ahead. Let's go.
The variables that were the things in the experiment that don't change.
Okay. So what were you saying? Okay, so tell me some examples. So you said the amount of soda you give each group. Okay, what else would be a controlled variable? Both groups get the same. So you're going to give them both, say, an 8-ounce glass of the soda. Okay, different kinds, but it's going to be 8-ounce glass of the soda. Okay, what else? How would you treat them the same? What are some other ways?
Give them all, like a caffeinated drink. Compose themselves to decaf people.
No, you can't do that because that's a different variable. Okay, so the control variable, so to make it a controlled experiment, the whole purpose is to make sure that the reason that you're getting your result is only because of that one variable and not something else. So we don't want any outside influence. We want to eliminate that as much as possible. So controlled variables, I just call it the equal treatment for both groups. Okay, so set amount of soda. Okay, so what if some of your test subjects are really, really old, and maybe the caffeine's going to cause them to have a heart attack. And we have some that are, we put really older people in one group, and we put a lot of younger people in another group.
That's a variable.
Not good. We either need to stick with the same age group, or we need to make it varied among, we need to have the same ages of people, okay? Or it can be very random. But you couldn't just say, okay, all of you old people go over here and all you young people get over here. That wouldn't be right. Okay, maybe you have people that are scared of the dark. Let's say we put some people in a lighted room and other people are in a dark room. Well, their heart rate's going up because they're anxious and they're scared. What if we put some in a really cold room and some in a really warm room?
I'd rather be in the cold room.
Let's say, it's really hot and you're like, oh my gosh, now your heart rate's going up too. So we want to give them the same environmental conditions, right? So if you just said same environmental conditions, you wouldn't get a full point on that. So you have to be really explicit. So if you said same environmental conditions, you would have to say such as, and kind of list some of those. So that way we know what you're talking about and you're not BSing us about something. So, so we'll say same temperature, even food that they get and amount of food, age group or age groups, light, etc. Okay, so any of those things, to make it controlled, you just have to restrict those and keep them consistent. Now, does that make sense?
Yes.
Okay. All right, so collect and analyze data. What is data or data? Okay, they can be in the form of observations, and that's called qualitative data. Okay? All right, what else?
Information that you gather from something.
Okay, so for this, so if this is any of the different types of data or data, info, experiment, yields. Okay, so it can be numbers. Okay, if it's numbers, it's called quantitative data. If it's something where you have other than numbers, so like observations, let's say there's a color change. Let's say that you're recording the mood of the person, their body language. So those would be qualitative data. So when you go to chemistry, one of the things that and it labs for us too, but I know Miss Wall, really, you have this data table, and she's always says, write down all of your observations. Well, your other observations would be a lot of these qualitative data too. So color change, mood, emotions, etc. Things that are more in the appearance and behavior would be qualitative. And then, so for here, we would do the same thing, and then the conclusion is always going to sum up your results. Results. But you compare them to your hypothesis. Okay, what if you say, well, gosh, my results didn't at all come out the way I thought they were going to come out. Do you change your hypothesis?
No.
You just say that my results didn't support my hypothesis, and that's where in AP, we actually do some statistical analysis and figure out something called standard deviation. Then we have to draw little error bars on our graphs, and we try to look to see how valid are our results. It sounds really scientific and really hard, but it really isn't. It is scientific, but it's not very difficult. But you also talk about that in statistics when you guys take those. So conclusion, then what happens after this that's not listed? What was our 7th step yesterday?
To share it with someone else.
All right, so you're gonna share out your data, and then what are you gonna do after that? Repeat it, because it just might be a fluke. It might just be chance, and or it could be you messed up one little thing, and then your results aren't valid at all, and you have to repeat it. So I'm gonna put report, repeat, experiment. And that's also to increase the validity of results. Okay, so that's what we're going to do now. You've been sitting forever. So what we're going to do is finish the lab sheet. So you had the What is Life lab on the front. So if you flip it on the back side, there's the little beating hearts lab. And in order to do this, you have to go to find your heartbeat. So you can find it here, or you can find it here. I don't have a lot of luck finding it right here. I always find it right here. So it's this sheet. Okay, so everybody probing around your neck. Can you find it? Or your wrist? Make sure that's your whole. Okay. Can everybody find it? Oh no. Right there. Hold your fingers like two, like that. You have to push on, yeah. I'm like, all right, everybody found it? Francis, you good?
Yeah.
All right. Okay. So you're going to be taking your resting pulse rate in just a second. So before we do that, look up here, and here's the whole focus of the experiment. So we're going to investigate the relationship between exercise and your heart rate. We're going to do that as a measure of your pulse rate. Okay, so what is the independent variable and what's the dependent variable in that sentence? The time. Okay, it's either going to be exercise or heart rate. Exercise is the special treatment you're going to do to your body. We're going to see how it affects you. So that is your independent variable. So what we did, as I told them, I was like, well, go ahead and underline that and put IV over it. When you read it, you want to just kind of go ahead and write down what you know. And then that means your heart rate, the responding variable would be your heart rate. So that would be your DV. And you've already answered 2 of your questions down below by doing that. Okay, so formulate a hypothesis that predicts the relationship between your pulse rate or heart rate and exercise. And you want to start with an if statement. Okay, so go ahead now and make your prediction. Okay. Once you've done that, find your pulse rate, and I'm going to time you. And instead of doing it for 30 seconds like it says, we're going to do it for only 10 seconds, okay? Because usually when we do it for 30 seconds, someone forgets, or like you zone out for a minute, and you're like, oh shoot, I forgot to count. So we're just going to do it for 10 seconds, okay? All right, find it. Use my phone. That way, reduce experiment or error.
It tickles. Okay.
You're tickling your neck.
No, it's just like I could feel it. I don't know.
Okay. Ready? Go. Stop. Okay. So write that number out down and then multiply by 6. And if you're not sure if you did it right, if you want to do it again before we go to the next part, then you can do it again. Okay, so you may want to do it again just to see if you were right.
Yes.
Okay. Ready? Good. Okay. Then multiply by 6. I want to hear some of your numbers because I'm curious.
The original numbers are after you multiply.
I got it now.
After you multiply.
I got
That's 78.
90.
That's really good. That's good.
I got those 50.
In the 60s, very good.
78.
That's not bad. That's not bad.
114.
What is the lowest? All right, does anybody have like in the other than 60s?
I got 54.
I have
I got
114.
78.
But
I don't
Tom,
think I did this right because mine was only 48.
I got 90. I have 114.
Jesus Christ, you were stressed.
I think
you are
Yeah.
stressed. Are you sure you did it? Because
Yeah, it's actually.
What did you multiply, right?
Yeah.
What number did
you want to just count the. You may have like that little back.
Yeah, you're
So it's like.
It's double time.
Hold on.
No.
Okay, so what this says is your resting pulse rate. If you have a lower number, then you have a bigger stroke volume. So that means that your heart is more efficient and pumps a whole lot of blood with little pumps. Okay, so that means you have a very strong heart muscle. It means you're probably more aerobically in shape. It means that you probably don't eat as much salt. You may not have, we have people that are your age group now that have high blood pressure. It's not good. It's all because of our crappy diet. And people are couch potatoes more than they used to be. So, but if you have a good aerobic heart health, you will have a lower heart rate. So that's okay. If yours is resting at 90 some, it could be medication. It could be if you smoke, because nicotine raises your heart rate. It could be birth control pills can raise your heart rate. It can be
I take
salt.
He takes both.
I might have said
control.
salt.
No, I think
In your
pills
diet.
for ADHD.
Oh, okay. If you take certain medications, stimulants obviously will stimulate your heart rate.
Oh,
So if I take Adderall, like if I were to take Adderall, which I do sometimes, I can always tell because my heart rate's higher than what it would be if I didn't take Adderall, which is ADD medicine.
Well, I have ADHD.
But I'm just saying, just know there's reasons for that. All right, now what you're going to do is you have to kind of pretend you've been sitting here and you're like dozing off and all of a sudden somebody just scares you and you like jump up. So you have to spastically jump up, and it's not like this, okay? You have to like spastically jump up, find it real quick, and then we're going to count, okay? All right, so don't fall over your neighbor or a book bag.
No, that means we're gonna hit the desk where
No, you're going to jump out. You got to go.
Desk keep with me. The desk went with me.
Yeah.
This desk is gonna come.
You can
with
like
me.
spastically.
Can we do a couple jumping jacks?
It says on paper that you jumping jacks like a minute.
All right, just get out and jump, and then
If
we're
I
going to
jump
start.
this
All right, ready?
This is gonna come with me.
All right, jump. Oh my God. Okay. All right, ready? Go. Stop. Okay. Okie dokie. So do the same thing, and let's see if there was an increase.
Times 6, right?
Times 6.
I'm just saying.
I don't even know. What are you doing?
I have 132.
Oh my God.
Mine's 108.
Jump up out of your, just
I
jump.
can't, I
It'll
hate
be.
the desk. It's dead out.
It's gonna be- just jump up and I'll time you.
Miss Turner, you didn't say like carefully jump out. You said go jump out so the desk will be with you. So,
Stop.
I went away. I was extra jump out my desk.
Okay, all right, so the next one is, it says jog in place, or do jumping jacks, or you can do push-ups, you can do squats, but you have to do something for a minute. Now, this is where usually we go outside and we're like jogging around that little circle, but unless you really want to.
Let's do it.
it's nice and cold.
I love
Oh
it.
my
It's so
God,
cold, it's so cold.
It is not cold. It is nice.
Actually kind of feels good. Right.
Good a little bit.
It feels good.
Last period, we just did either jumping jacks, run in place, or you can do squats, But if you do squats, if you do squats, it can't be like one squat. You know what I mean? It has to be like,
Irish stance, so my version of the Irish stance.
you have to stick your butt out, get down, good form.
Every morning aerobics.
I'm gonna do my.
Like our dry land.
Miss Turner, if we're gonna be in here, I'm gonna do my version of the Irish stance.
Why do we have to do
You can Irish dance for a minute. I don't care.
Okay.
All right, so everybody find a spot, spread out.
All right, well, stay away from me because I'll be cooking in the air. No, I'm serious. My version of the Irish stance.
Okay. And if you want to do an exercise video in front of YouTube, have at it.
Wow.
All right.
Wait, that's recording?
Yeah.
Oh my goodness. That's recording.
Okay. It's just recording the board right now. Okay. Ready? Go. Not to lose my board. Good form, Dominic. Good form.
I did that for no reason. Just to make my brother.
Good form.
I keep my brother.
All right, 20 more seconds.
I'm gonna die.
Jada! There you go. Mix it up, bro. Mix it up. Oh my gosh.
I'm gonna die.
All right, ready? Stop. Okay, now. Go.
Touchdown.
Stop.
No.
I don't wanna know what these things Never done the conversation.
Where's your business partner?
All right. So if you are in good aerobic health, your heart rate going up is great. It's fine. But the fact that it comes down quickly back to your resting rate, that's great. If you're still panting after a while, then you probably need to go get the AED. So, but anyway, so getting your heart rate up is a great thing. It's just,
I have
when it comes down.
192.
Wow.
My hypothesis is correct. It increased.
There you go. You did it for just for in the name of science, yeah. Okay. So after you have that, so go ahead and put in your independent variable because everybody's experienced that, and then your dependent variable. You can just list that on the blank. And then when you go down to conclusion, look at your data and explain your data in a sentence or two of what your conclusion was.
23 minutes until we leave.
And then when you get down to 4, you're going to say, was your hypothesis correct? You're going to say your hypothesis, your data supported your hypothesis, or if it did not support your hypothesis.
Can I not just say yes?
Mm-mm.
I already wrote that.
Right, because of what?
You're either going to say that your data supported your hypothesis, or you can say that my hypothesis was supported by my data, or the data supported my hypothesis. Or if it did not, you may say it was inconclusive because maybe you got some erratic trend in data. You're like, this isn't making sense. Then you can say, however, it's necessary to repeat the experiment.
I remember one time we did the same thing in 5th grade. I don't know.
Okay. And then once you're done, you're going to tear it out, make sure your name's on the front. You can turn it in.
What was the independent variable?
Let's pass them to the front, then we'll just filter them kind of off. But keep writing. If you're not done, that's fine. Just finish them. You can't say just it has an increase. It is what? You got to use more explicit language.
I'm asleep.
I'm awake.
I'm not sleeping anymore.
I am still tired. That did not hear.
Looks like I have to drive today.
Stay off the road if you're walking.
Okay.
What does this say?
That is an LD50 graph. That is actually an AP environmental little,
Oh, it's
Intro
that's right
graph.
here, because I just clicked on it.
that's a separate one, yeah.
This is separate.
Okay, so we need to practice graphing. If you're still writing, that's fine. Keep on writing. Just turn to this one, and we need to make sure we know which variable goes on which axis before you can plot the data.
Oh, I did this. I did this.
And I want to make sure, y'all tell me what you know about graphing. Like, how would you get all of your points on graphing? So that's what we've got to kind of go through. Like, what are the ways you can get all of your graph correct? Okay, hold on there. There's something else that we need to do. The independent variable will always be on the x-axis. So whatever you identify as your independent variable, that'll go on your x.
What is funny thing about this board? This one.
Okay, so let's look at this one, and someone read right here who doesn't mind reading right where the. Okay, Jada, saw you first. So you read this first sentence. That'll help set up the stage. We'll be able to figure out what's the independent variable, what's the dependent variable, I think.
You have measured the rate at which the fish breathes at various temperatures by counting the rate at which its gills open. The data is below. The graph is there.
Okay. The rate at which the fish breathes, or it says breaths, but technically it's gas exchange. They don't really breathe. If they had lungs, they would breathe, but they have gills. This is a lab that we've actually done before. And what you do, what do you think you would count to figure out how quickly a fish respires or exchanges?
Still little gills.
It's your bills.
And do one of two things. If it's a bony fish, no, not a shark, because those are cartilaginous fish and they just keep their mouth open and swim. But if it's a bony fish, they gulp. So you can do mouth openings or you can do opercula openings. So you would count one or the other. And we've done this. We did this lab. You would have to lower the temperature down and count, and then you would raise it up. And usually we'd kill several fish when we did it. So we stopped doing it, but then I found this and I was like, oh, we'll just use this. But so anyway, that is the mouth openings or gill openings or opercula per minute, it looks like. So what is the independent variable? What is what you're going to change, and what is the result? Okay, so what's the independent variable?
Temperature.
Right. Okay, so temp is going to be IV. And the rate at which the gills open is going to be your dV. Okay, so they're saying that is going to measure breathing rate or the number of openings per minute. So where's temperature going to go, do you think? The IV. No?
On the X.
It's on the X, always. So independent variable x-axis. So we're going to put X, and then we're going to put this on the Y. So down here, we're going to always label each axis. Now on the AP exam, it's interesting. You only get 1 point for this, but if you get 1 point for labeling each axis correct, okay, and out of 10, and the increments correct. Okay, so if you set it up right, you get a point automatically, which is great. And then you would plot your data. Now, because this is two sets of numbers, it has to be a line graph. It has to be a scatter plot. If it wasn't, so let's say it was like some qualitative data, like maybe we're trying to investigate the type of fertilizer on the growth of plants, the type. Well, there's no numbers about type. It's just a type, right? So that would be, we'd have to do a bar graph. So if you see a bar graph, usually there's no numbers on the x-axis. It's usually numbers on the y-axis. So that's just kind of my honor slant on that. For this, because it's numbers, it's gonna be a scatter plot or a line graph. Okay, so temperature, what are the units? This is the next thing, you have to put the units, always. So what are the units for temperature?
5.
No, units, not increments. Celsius. So we're gonna put degrees Celsius, okay? So if we look at that, what should we number by, do you
5.
think? 5, okay, so 5, perfect. Okay, so we're gonna go ahead and do that. Okay, and now on the y-axis, what are we gonna write?
Breaths per minute.
Okay, so. This way. So, openings. Okay, so I did that. We could be respiration rate, gill openings per minute, mouth openings, whatever it was that we were counting. Okay, so what are our increments going to be for this? What is the lowest and the highest number? What's our range?
5 and 30. So let's probably make it by 5 too.
Let's see.
Oh, wait, wrong numbers.
Well, up to 37 though, right? So
By 5.
can we do by fives again?
Yeah. That's
Okay.
5.
I'm just not gonna label each one of them. We'll skip. Okay. So independent variable, we've already identified. And then this is pretty nice. Okay. Now, if you were turning this in to me, I mean, I wouldn't put B rate, but you know, this is just for you to practice. So, okay, best type of graph for the data. What did we say?
A scatter plot.
Yep. Y to
Going off.
I just put 2 sets of number data or numerical data. Okay. All right. So now plot the points and let's see what you get. And we're not going to do, because it's not a true scatter plot in that we have all those outliers. And you know, you guys are taught to kind of draw the line between all those dots, right? This one we're just going to connect the dots. Okay. So. Does anybody else talk to yourself when you do stuff like this?
Me.
I'm over here talking to myself, so I'm not crazy. It's just what I do. Some days I feel like it, really. All right. Okay. So 25 degrees is about, gosh, 70, maybe 2 degrees Fahrenheit. What we find is we would raise the temperature up to 40 and it would start to go down because it was struggling. So what are you going to say? What happens to the breathing rate with an increase in temperature? Yeah, it increases. Absolutely. So what would be a good control for the experiment? Because I should have asked that earlier. Is this the control group or the experimental group?
Control.
This? Yeah, so this is an experimental group. But what would you do to create a control group? Exactly. same time increments. And you would run the temperature. I mean, you would run the experiment the same amount of time, but yeah, you would just say 25 degrees Celsius. Just use room temperature, and you would keep it constant. So you're exactly right. So how do you think the breathing rate was measured? So we already said that, either the gill openings or the mouth openings. I think it was gill openings per minute. What do you think would happen if you raised the temperature even more? Okay. So what happens as you raise temperature? I don't know if you guys know this. You might. And so, I mean, if I'm insulting your intelligence about any of these little facts, just let me know. It's okay. Does anybody know what happens as you raise the oxygen levels, as you raise the temperature? You might have learned it in our science.
You just said it. You just said it. You raise the oxygen.
You do what to
There's
it?
more oxygen in the water
As it gets warmer or as it gets colder?
as it gets warmer.
It's one.
I think it's
No,
because
if
it
it
gets
gets
too
too
warm.
Yeah, dissolved oxygen actually decreases with temperature. So how do you know this is my trout in this aquarium, they have to have it at 60, like 61 degrees. And it's because they like a clear, less turbid water. They like a high oxygen content. So I have like a bubbling rock in there. The water's constantly falling to add oxygen because there's no autotrophs in there except some algae. And they're not producing a whole lot of oxygen. So I have to add oxygen to it. But cold water, think about this. This is how you know. If you put a soda that you open in the refrigerator and you put the lid on really tight, does it stay fizzy longer in the refrigerator or if you leave it out on the counter?
Refrigerator.
It does. So anytime you open one of those, put it on really tight, stick it in the refrigerator, it'll stay fizzy a lot longer. So when a soda gets hot, what happens to it?
Flat.
Because all that CO2 gas goes and it leaves the solution. That's how you
All the fish I've ever had died. Like every
dissolved
time
oxygen.
it
The
just
truth
died.
comes out.
Yep. So that's just another fact because I mean dissolved oxygen, it is definitely a function of temperature in the water.
I lost. I used to have shrimp and I lost them. They were ghost shrimp. And they just disappeared. I don't know what happened.
Sea monkeys.
They
That's what we
disappeared.
call
I don't know what happened to them. They just, I cleaned up the tank every day. I put all the fish back in there and the shrimp gone.
Oh, ghost shrimp. I was
Yeah, the
thinking
ghost
about the little
shrimp.
brine shrimp, sorry. Totally something.
Ghost shrimp. Them Johnson's gone.
Something probably ate it. The fish ate them.
No, we had like little goldfish. I don't think they ate it. I don't think. I don't even know if I had.
Yeah.
No, I had guts.
You probably had 3, 7.
I was just chilling one day.
No, we still have 8
Give
minutes.
it to him. Okay, cool.
You know,
Okay, so
when I was little, and I was really sad.
My hamster almost got loose.
so let's just mark something for homework, and I want to get you started on the back. So you've got this
You just said.
as it relates to the graph on the back. So you'll answer the questions based upon this data. And then this is an LD50 graph that I thought we can start it and then you guys will be able to do it. It's actually really interesting. This is something we have to do in AP Environmental Science. And we actually, LD50 is lethal dose 50. That means at what dose does it kill 50% of the test subjects? We do this with brine shrimp or with water fleas. And we give them a environmental poison. So what we do is we give them really low doses and we count how many's there and then we give them a next, like a bigger dose and then we count how many's there and we increase the dose until we kill them all.
They died.
Then we have to we figure out what is the lethal dose. This is what they do in pharmacy. If you're interested in pharmacology at all, you learn LD50 of different substances. And that's why they always at the doctor's office, they have to weigh you because they know what the lethal dose is of different medicines at your weight. So they know what is the correct dosage that they should give you. So do you know what one of the most lethal chemicals there is?
I want to say acid.
It is, but it's not. It's something you would be really shocked. It's considered super toxic.
Hold on. Bleach?
Could be something like you're.
Not even bleach.
It's on the pH.
What is that? What'd you say?
Oh.
Not codeine,
Oh, I'm just saying water. I don't know.
caffeine.
Oh, that makes no
That's
sense.
a caffeine.
It is. It's very addictive.
It's addictive and it could
I'm
kill you if it
addicted.
gives
I
you a
love
heart
caffeine.
attack. Heart-
But caffeine, yeah. The other one is Botox, like botulism.
That reminds me.
What they use for Botox shots.
That reminds me, caffeine actually reminds me of this, those, comic where I saw online, where it was a guy, he drank like 50 cups of coffee like in an hour. And,
There is a legal dose.
hold on, listen, and his heart just like came out of his chest and said, I gotta go run. So it was hilarious, I laughed for like an hour.
I mean, I know where
All right, so homework is you're going to plot this point. It tells you how to find lethal dose 50. It's really kind of cool. But we've done this actually in multiple choice questions and essay questions for 8s. So I thought I'm just go ahead and give you all this and give it a shot. So do those 2 things, and then your ticket out the door is actually on a little sheet of paper I'll give you. So you just need something to write with. You can pack up.
I'm gonna look at the comments if there's, you guys are right? Yeah, but the heart, I think, see the heart said, I gotta run, or. But it had like arms on the legs, it was like this, like eating down the road. And the guy was just sitting there like this. What?
Yes, absolutely.
Are they able to
Oh, yours
turn your
is
back?
the succulent over there, right? Yeah.
What's on here? Are they able to like turn, and then your back just starts cracking a little bit?
It just releases the air spaces.
I know. That reminds me, I could do this, I could do this weird thing. I can make the correct sound with my elbow.
We'll go. I'm bigger, and I've always thought them. I still think this makes them bigger.
Can we make the correct just by doing this? So weird.
Absolutely. All right.
That's what I feel like.
3 minutes to a trice, 3 minutes to a
Hold on.
scientific method.
Okay, so as far as the scientific method goes, that includes graphing and all that stuff. Just 1, 2, and 3. One thing that you know you've mastered, you've got it. You don't have to worry about even studying it again. The second thing is you're almost there, but maybe just a little bit more practice. You're almost there. And then the third one is something you do need more practice, you feel like, and you might not have anything. So it goes back to a prompt of design an experiment that tests this problem. Can you do it today? If you feel really confident, then you may not have anything for number 3. So just one thing for each, just so you're reflective, and that helps me know too of what I need to incorporate later. Because we won't have another day. Tomorrow we start the chemistry of life. So. And then once you're done, all you have to do is start a little stack over there on your way out. So.
Here you go. You can put a cherry on.